Today we will discuss the Thyristor gate characteristics. As you can see in the diagram, the form of graph between gate voltage and gate current is shown. So this graph is first of all plotted between gate voltage and gate current. Students usually forget this. It is between the gate voltage and gate current. Here the positive gate to cathode voltage is Vg and positive gate to cathode current is Ig. These are the DC values. A gate cathode circuit of a thyristor is like an PN junction. Gate characteristics of this device are usually similar to an diode. So particularly we have taken two curves so that we can find out the safe limit where the thyristor can operate. So graph curve 1 and curve 2. This is the curve 1 and this is the curve number 2. Both these curves are drawn so that we can get the safe limit of operating of the thyristor. Here VGM is the maximum value of gate voltage where the thyristor can operate safely, and this IGM is the lowest voltage that must be applied to make the thyristor on. So both the two values we have taken. Also we have here OY, which represent minimum gate voltage. OY and X represent minimum current. Here OA represent non-triggering gate voltage. While designing the graph or while doing in exam, we should remember it is plotted between the VG and IG, that is gate voltage and gate current. Also we can remember the maximum limit and the minimum limit. Then OY and OX are the minimum gate voltage current to trigger an SCR of voltage and as well as current. Also OA is a non-triggering gate voltage. So what happened with this, after that we have taken P average. We have joined this both the lines to make the value P average. So this limit should not exceed the avoided to permanent damage of the junction J3. As we know, the in junction J3 the charges are still trapped for the favorable for the conduction process. So we have talked about non-triggering gate voltage, this OA. A non-triggering gate voltage is prescribed by the manufacturer of SCR. It is always written over there over the SCR by the manufacturer. So if you look at the equation, what we get is the gate source voltage. This is a gate source voltage. This is the gate cathode voltage. This is the gate current, and this is the internal resistance. So we got this value. The internal resistance RS, this internal resistance should be triggered in such that ES upon RS is not harmful to the source as well as gate circuit. So in case of lower values of RS, an external resistance must be connected in the parallel. It also provides a path to the leakage current. Also we can plot the graph here between gate voltage and gate current, and this is same as the previous graph, but here what we have done, we have taken the value ES. We have taken the value ES at point OA. OA is the drawn as AD. OA is drawn as this AD. So now after when we draw this, it intersect at 2 points S1 and S2, and in between this point, this is P average, we have got this point S. It can swing in both ways, that is S1 and S2, but the prescribed limit is this: thyristor must operate in between this to avoid any kind of damage. Thank you very much.